Now we are going to talk about the gas laws. Gas laws. And the simplest form of these laws is known as Boyle's law. And it's very simple, which is that the pressure times the volume of a gas is a constant, K. So what does this mean? If you have a fixed volume of gas, so here's your gases, and a good example is this is your car tire, right? It's a volume of gas and it's under a certain pressure. Stick a little pressure gauge in here and it's 100 psi, right? Okay. If you change the volume of the gas, let's say you have now, let's do this example. Let's say you have a piston inside a cylinder. I'm sorry, this drawing's not working very well. Let's redraw this. Okay, hold on a second here. So let's do the famous example of here's a cylinder, and inside the cylinder is a piston. And so you have a certain number of molecules of gas with a certain temperature zooming around inside your cylinder, and you measure the pressure, say 100 psi. Now you are going to cut the volume in half by compressing the gas, by moving the cylinder up. Now I'm erasing some of these molecules, but in reality they're just getting squished. So now there's more of them in one place, right? And the cylinder has gotten half the size. Well, the volume got cut in half, so the pressure now has to be twice what it was before. So now we have 200 psi. And so this is all that this law states, is that the pressure is inversely related to the volume. So you can rewrite the equation. The pressure equals K divided by V. So if V gets bigger, then pressure has to get smaller. And if V gets smaller, pressure has to get bigger. Likewise, if you change the pressure, then your volume has to get bigger. If you're going to, or rather, if you change the pressure, then the volume would have to get bigger to maintain K. So in any case, you have this relationship, PV equals K. And this was Boyle's law. Now there's one caveat to this law. The temperature has to be constant for it to be true. And in practice, this is generally never the case. For example, when an engine has a piston, when that piston goes up, it happens very quickly and it compresses that gas. The temperature rises because you're confining that kinetic energy in a smaller volume. So Boyle's law only holds under very special circumstances. So let's talk about the more general law, and this is called the ideal gas law. And again, you might get the idea from the name of the law, the ideal gas law, that is talking about some fictitious ideal gas. And that's true. Real gases are yet more complex, but this is a good approximation for a lot of gases. So we call it the ideal gas law. And it has the form, well, let's talk about what happens first, okay? Again, we'll take our piston example. This time, we can make provision for the fact that the temperature is allowed to change. So here's a piston. This is situation 1. We take the same cylinder and now we pull the piston down. What's going to happen? Well, the gas is going to expand. So the pressure has gone down, but also the temperature is going to go down because the gas is now, the kinetic energy is dispersed over a larger volume, so the molecules actually slow down when you do this. So the temperature goes down. So you end up with this equation. Pressure times volume equals the number of moles of atoms, N, times a constant called the gas constant, times the temperature. You can rewrite it this way. If you want to just get the idea of the equation, it's proportional to temperature. So look what happens. This is something that you will experience on an everyday basis with everyday things such as balloons. Let's take a balloon. Here's a balloon. And it's got some gas molecules in it. And this works really well with those silvered balloons, like a birthday balloon that says happy birthday on it. It's silvered. Take that balloon and it's kind of, let's say it's been sitting around for a few days, so it's kind of a little bit deflated, right? If you increase its temperature, what has to happen to its pressure and volume? It has to go up, right? That's what the equation says. So you heat this thing. You put it in front of your Toyo stove, not too long so it doesn't melt. So here's hot air coming in. The balloon is going to, what's it going to do? It's going to get bigger. And you can see this very readily, again, with those silvered balloons. The balloon is going to increase its volume a little bit. Same number of molecules, but now they have a higher kinetic energy, so the volume is going to get bigger. Likewise, if you squish the balloon, and let's do it this way. Let's use our cylinder example again, and look at some more of the implications of this equation. Let's say you have your cylinder with your piston in it, and so here's a piston, and here's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's the molecules in your cylinder, and you squish the gas. Okay? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now, your pressure has gone up, and your temperature has gone up. But if you bring your temperature, or if you want your pressure to be the same as it was before, what do you have to do? You make it colder. Then your temperature will be the same as it was before. So you can move these three variables around any way you want and get useful information about what's happening with your gas. We will look at some online videos about the gas law and about the states of matter. And then you'll be doing some interesting labs this week involving implosion, which should sound exciting. I think it's exciting, at least. And it's related to the gas law. So I hope you have enjoyed these short lectures, and please continue the week online. Please continue this week's online lecture or online material with some of the online videos that I'll be posting, and of course with your homework and quiz. Okay, bye.